The Sun is very old. It is one of 100 billion stars in our Milky Way galaxy. Scientists estimate that the Sun is about 4.5 billion years old. We never measured the age of the Sun directly, it would be impossible. All that we have are indirect methods to estimate it. To have an idea, we look at the age of the whole solar system because we assume it all came together around the same time. To get this number, we look for the oldest things we can find. For instance, moon rocks work well for this. That's the reason why when astronauts went to the moon, they brought some rocks back for scientists to study them. They were able to find out how old they are. A really important thing to know is the composition of the Sun. Observing it in the sky, we might think it has the shape of a ball, or we could suspect it is a sphere. Sure, that's true, but how is it made? Well, we know that the Sun is not solid. It is composed of plasma, a material made from electrically charged gas atoms. It is about 75% hydrogen and about 25% helium. The remaining traces are tiny amounts of metals. A really interesting thing is that Jupiter has the same composition as the Sun. If the Sun were smaller, it would just be a huge ball of hydrogen akin to Jupiter. The hydrogen in the Sun's core is held together by a lot of gravity, resulting in high pressure. The pressure is so high that when hydrogen atoms collide with enough force, they create a new element, helium, in a process called nuclear fusion. The continual nuclear fusion causes energy to build up, and the Sun's core reaches temperatures of about 27 million degrees Fahrenheit or 15 million degrees Celsius. The energy then radiates outwards to the Sun's surface, atmosphere, and beyond. We can feel this energy on Earth. We can feel the heat of the Sun on our skin. It's what helps us dry our clothes every day. The amazing thing, however, is that the Sun is really far away. It is about 93 million miles away from Earth. If we wanted to sort all the planets from the closest to the furthest, we would come out with this list: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, with Mercury being 35 million miles away from the Sun and Neptune lying 2.8 billion miles away from it. An easy mnemonic often used for remembering the order is, "My very educated mother just served us noodles." But I think it's time to change it because it might sound a bit sexist. Do you have any other simple ideas? Let us know in the comments below. Oh, I forgot to mention that the Sun is huge. It is about 865,000 miles in diameter. To get a better idea, that's as wide as 109 Earths placed side by side. Oh, and something like 1 million Earths would fit inside the Sun. Amazing, isn't it? This giant object wanders in space. What we know is that it moves very slowly. The Sun is the center of our solar system, of course, but it doesn't stay in one place. It orbits the center of the Milky Way galaxy, and it takes the Sun about 226 million years to go around the galaxy once. For comparison, the dinosaurs went extinct around 65 million years ago. However, not only the Sun orbits the Milky Way center, it also rotates around its axis in the same direction as Earth does, i.e. counterclockwise, when looking down from the North Pole. But sections of the Sun spin at different speeds. Because the Sun is gaseous, different sections rotate at different speeds. At the surface, the area around the equator rotates once about every 25 days. The Sun's north and south poles rotate more slowly. It can take those areas more than 1 month to complete one rotation. The Sun has a lot of pull. It makes up more than 99% of the total mass of the solar system. Being this massive, the Sun exerts a lot of gravity or pull on the planets, enough to cause them to orbit around it. When people understood this, it was mind-blowing. The Kepler laws describe how the planets orbit around this pulling monster. Believe it or not, the Sun's gravity is about 27.9 times that of Earth's. Don't ask how, but astronomers found a way to quantify the energy coming from the Sun. What they discovered is unbelievable. The Sun is an enormous ball of energy. The Sun's core is under a lot of pressure. Because of this, hydrogen atoms are constantly colliding with each other at great speeds, fusing to form helium and releasing energy. But where does this energy come from? Well, lots of these collisions occur, creating an enormous amount of energy. Think about this. In just 1 second, the Sun produces about 118 trillion times as much energy as the United States used in the year 2003. Fact number 8 might seem obvious, but It's worth reminding you that the sun is hot. Even if it is not your boyfriend or girlfriend, its temperature is not constant. It varies over time and through its 8 layers. One thing is sure, the hottest part of the sun is the core, at 28,080,000 degrees Fahrenheit on average. And did you know that the sun has spots? This is due to its magnetic field. When the sun's magnetic field pokes through the surface, it prevents the heat rising inside from coming through. Some kinds of tubes are created where the divergence of the magnetic field is constant, making the pressure lower in the tube and therefore lowering the temperature. As a result, the sun's surface in these areas is cooler and darker than its surroundings, although still very bright. These dark areas are called sunspots. Sunspots are not permanent and they can move slowly across the surface of the sun, changing size as they move. By observing them, in principle, one can get the rotation velocity of the star. The appearance of sunspots on the sun also follows the solar cycle of 11 years. What does this mean? Every 11 years, there will be a period of increased sunspot activity. Sunspots vary in size as small as 10,000 miles across to as large as 100,000 miles across. The sun has a magnetic field, but do we know anything about its shape? Well, as a first approximation, the magnetic field of the sun has a spiral shape. It's called the Parker spiral. As the sun rotates, its magnetic field twists into what's called an Archimedean spiral as it extends through the solar system. This phenomenon is also called the Parker spiral after Eugene Parker's work. This guy predicted the structure of the interplanetary magnetic field. Did you hear me well? He predicted it with equations. The influence of this spiral-shaped magnetic field on the interplanetary medium or solar wind creates the largest structure in the solar system, the heliospheric current sheet. You should be careful not to get too close to the sun, and that's because you could get instantly pulverized. We know this because sometimes areas of the sun suddenly appear much brighter. These bright spots are called solar flares. They are areas where large amounts of energy is released to the surface of the sun. Solar flares emit bursts of electromagnetic radiation, including high-energy X-rays and gamma rays. The energy released by a single solar flare can be more powerful than 1 million nuclear bombs going off at the same time. Here's what they look like. These monstrous flares are made of particles, and when they are released, they can reach Earth in just a few minutes. These particles can damage electronic components and satellites and can also affect some radio signals. Perhaps the most important fact about the sun is that it's a pretty average star. Our sun is not so special in the universe. It is an average-sized star. There are smaller stars and larger stars, even up to 100 times larger. Many other solar systems have multiple suns, while ours just has one. Our sun is 864,000 miles in diameter and 10,000 degrees Fahrenheit on the surface. For instance, we have found stars that are 100 times bigger in diameter than our sun. Truly, those stars are enormous. We've also seen stars that are just 1/10 the size of our sun. For instance, the sun would be just a small dot if compared to stars like Rigel and Aldebaran. However, maybe the sun is a bit unusual in the sense that we don't find it in a multiple star system. It is not bound to any other close star. It's just one sun surrounded by planets, asteroids, comets, and dwarf planets. But solar systems can have more than one sun. That's often the case. More than half of all stars are in multiple star systems. That means that in general, other star systems have 2 or more suns in them. Can you imagine having 2 suns in the sky at the same time? Well, there are plenty of planets throughout the universe where that is normal. Multiple sunsets, multiple sunrises. What a life that would be, or maybe not. The sun is approximately halfway through its lifespan. If it was a person, we could say it's almost 40, I guess. Since we said it was 4.5 billion years old, it still has something like 5 billion years to go. And when those 5 billion years are up, the sun will become a red giant. Our star will get bigger and colder at the same time. When that happens, it will be different than the sun we know today. As a red giant, our sun will become about 2,000 times brighter than it is now, and we would be long gone, hopefully. Without a doubt, if you were to list the most important things in the solar system we live in, the Earth may be number 1, but the sun is number 2.
And for all the reasons that you might expect to know, its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Electric currents in the sun generate a magnetic field that is carried out throughout the solar system by the solar wind, a stream of electrically charged gas blowing outwards from the sun in all directions. The connection and interactions between the sun and Earth drive the seasons, ocean currents, weather, climate, radiation belts, and aurora. In short and in long, the sun is vital to just about everything we do on this planet. And we rely on the sun to do many things, even though we're honestly not controlling anything that it does. Which is a bit of an odd thing for humanity, as humans like to control everything that has to do with us. The sun is something we see almost every day. Obviously, unless cloud cover is blocking it or an eclipse is happening. And even when we don't see it, we feel its presence. It's more than just a ball of light in the sky. It's an energy source, a lifeline in many respects. And as noted above, it helps shape our planet in various ways that would be detrimental if it wasn't doing it. So if someone was to honestly ask you just how important the sun is, you should tell them all the ways we need the sun, our star, to shine on. The sun's formation. Let's talk about how our sun got formed, shall we? Long before our solar system was born, the universe was a big wasteland of nothing. Or at the very least, that's what we believe it was. Then, through one means or another, there was an event known as the Big Bang. This expansion of energy and matter spread throughout the universe, both known and unknown, and created a great many things. And when it didn't specifically create something, it left the building blocks to all things to be made. In regards to our solar system, that would be what is known as the solar nebula, or to break it down for you, a massive cloud of gases and matter and particles and molecules. But how does it go from a massive cloud to a bright ball of warmth and energy we call the sun? The answer to that is time, pressure, and a little bit of luck. Most scientists who believe in the solar nebula theory understand the concept of the cloud being there and then somehow starting to make the planets and the sun. But what many aren't sure about is the actual event that led it to folding in upon itself. What we do know, or at least can theorize, is that when this started to happen, when the solar nebula started to destabilize, it compressed upon itself. And when you have a massive thing of gas folding in on itself, things tend to get massive. And as the cloud began to compress, it also started spinning, until eventually there was a giant pancake disk spinning around in our solar system. Not exactly a sun, but a big step in getting there. In fact, most label this as a protostar, and when that happened, the sun was born, right? Not exactly, because while it was a protostar, it was still a pancake. It's estimated that over the next 50 million years that the sun slowly gathered more mass and more energy from the cloud, likely due to its spinning nature and the gravity it was exuding. Eventually, once it got enough mass and energy, the process of nuclear fusion began in the sun, and that led it to being the big ball of light and fire that we call the sun. So a major piece of our solar system had been made. All told, our sun is believed to be as old, or pretty close to being as old as our whole solar system, which would mean that right now our sun is about 4.5 billion years old. How its formation affected the solar system. But that's not the end of the story in regards to formation of our system. Because as noted earlier, the sun has a massive gravity to it, and that gravity started to reach out across the barren parts of the solar system and started to make things happen. Though as some noted, it wasn't exactly a masterpiece of creation. Many speculate that when the sun got fully formed and its gravity loomed large, things just happened. This is one of the reasons why there are so many objects in our solar system, and why there are so many different kinds of planets. Some of the planets are gas giants because that's all they had to work with, or they had solid dense cores and the gases just run to that. And when they were big enough, and such regular matter like rocks and stuff couldn't stick to it. In contrast, planets like Earth, Mars, and others were able to go and be solid because of the matter that was around them. The gases of the nebula were still a part of them, but they were absorbed either into the ground or into the very atmosphere itself. As things formed, things slowly changed in how the solar system worked, again because of the star. Once objects were a true certain mass, they went into orbit around the sun. Other objects were launched into space or pulled closer to the sun and collided with other objects. Some think that this is what happened to the Earth that caused the moon to be formed in a roundabout way. All told, the way our solar system looks right now is because of the sun in large part. Thus, we owe it more than we could ever realize. Atmosphere. Above the protosphere lie the tenuous chromosphere and the corona, crown, which make up the thin solar atmosphere. This is where we see features such as sunspots and solar flares. Visible light from these top regions is usually too weak to be seen against the brighter protosphere, but during total solar eclipses, when the moon covers the protosphere, the chromosphere looks like a red rim around the sun, while the corona forms a beautiful white crown with plasma streamers narrowing outward, forming shapes that look like flower petals. Strangely, the temperature in the sun's atmosphere increases with altitude, reaching as high as 3.5 million degrees Fahrenheit or 2 million degrees Celsius. The source of coronal heating has been a scientific mystery for more than 50 years. The end of our star. Defining the end of a star's life is a bit more complicated than you might expect, mainly because stars don't die in the traditional sense most times. They go into different phases of life and sometimes die in order to create new stars. In the case of our sun, which is a yellow dwarf, it'll die in its current state in about 5 to 7.5 billion years, depending on who you ask. When that happens, it'll become a red giant, which is significant because these are much bigger than yellow dwarfs. In fact, when that happens, the Earth will honestly die, because the sun will swallow it up in its new state more than likely. Some even speculate that the red giant could consume everything up to Jupiter. Again, this is many billions of years away, but it will happen. And much like the sun made our solar system, the sun will also help to destroy it.